Alright, so today is the last day of Unit 5, and we are going to use the concepts that we've been doing throughout the chapter and relating it to word problems. So you need a formula. It's the thrown object formula. It's negative h equals negative 16t squared plus vt plus s. This is an s. And t represents time. There's two different heights. There's an ending height and a starting height. So please make sure that you know the difference. Most of the time, the ending height, it says how long until this object lands on the ground. So if it says ground, the ending height is going to be 0. So a lot of times that h is a 0. But not always. Sometimes the starting height is a 0. Okay. V is velocity. That's your speed. Right? So we're going to use this formula. You might see this formula in physics too. So basically it says if you've got an object that's being kicked or thrown or launched or whatever from somewhere over here, the path of that object is a parabola. So it has a highest point, here's the maximum point, and eventually it's going to land somewhere on the ground. Right? The rest of the parabola would continue here into the negative area. But essentially what you're finding is where is it going to, how long will it take to have a certain height. It may not always ask you for the ground. It may say, well, how long before it's 100 feet off the ground? So if it asks you that, then they would want to know, well, it could be here and here. So it's possible that you get two solutions. Okay, so these are the steps we're going to follow. You could pause the video if you need to, but we're going to move on. All right, so it says you launch a model rocket from the ground. That's your starting amount. This is where you start. With an initial velocity, so here's your velocity, of 95 feet per second. Now, this could be launched going upwards or downwards. Assume that it's upward. Right? If we're launching a rocket, it's shooting upwards, unless they say otherwise. Okay, so this is a positive 95. That would be our velocity. Our starting height is 0 because it's starting on the ground. It says, after how many seconds will the rocket have an altitude of 114 feet? Well, altitude is our height. This is our ending height. So that would be the scenario like here. We're wanting to get an ending height. So we'll have a couple locations where we'll have that height. So that's our height of 114. All right, so now we just need to substitute into our equation. So h is 114. Negative 16, that's just the acceleration due to gravity in feet per second. So it's always going to be negative 16. T is time, that's what you're looking for, right? After how many seconds? That's the thing we don't know. All right, plus our 95 feet per second velocity, so 95t, plus our starting height, which was 0. Okay, so first thing you're going to do is substitute the values into the formula. Then you need to put the equation into standard form. That's typically how we're going to solve. Or you can use the square root method if there's no middle term, if there's no x term. But in this case, we have an a, a b, and a c, or we will have an a, a b, and a c once we move the negative 114 over. So we're going to make it equal to 0. So we have 0 equals negative 16t squared plus 95t minus 114. So since we have an a, b, and c, right, if b was missing, we would use the square root method. But since we do have a, b, and c, we're going to use quadratic formula. So just like you did the last couple of days, quadratic formula means identify a, b, and c. Okay, and then you're just going to substitute into our formula. So we have negative b plus or minus, we'll call it t equals instead of x equals, 95 squared minus 4 times a times c, all over 2 times a. All right, so negative 95 stays as is. 2 times negative 16 is negative 32. And then this we're going to substitute into our calculator just like we did before. So leave off the radical part. All these answers should be positive. So if you're getting a negative discriminant, that means you did something wrong in your calculator. So make sure you have a positive number. But now we don't want an answer like what's the square root of 1729 because we need to know how many seconds. So a radical answer doesn't make sense. And so we're rounding to the nearest hundredths, which means use your calculator to actually get a decimal approximation. So square root of 1729 gives me negative 95 plus or minus 41.58 over negative 32. So now remember, if we have an actual number, you're going to split it up. One answer is where we have the plus sign, and the other answer is where you have a minus sign. Okay, so do this in your calculator. Negative 95 plus 41.58, then divided by negative 32 gives me 1.67. Or if I were to subtract, it gives me positive 4.27. So in this case, I have two instances, and I have to answer in a complete sentence. So how many seconds will the rocket have an altitude? So after 1.67 and 4.27 seconds, the rocket's altitude will be 114 feet. All right, so that means that this rocket was launched from the ground, right, 114 feet. Let's say that that's right here. You're finding these two values. So one other thing you can do is you could put this in your calculator. You could graph negative 16t squared plus 95t minus 114. And I'm going to graph. Now it goes up and down, and if I change my window to make my y max to like 200, you'll be able to see it better. So there's the path. Oh, I guess you don't need it that high. Let's call it 140. All right, so here's your graph. If we go to y equaling, oh, I know what I'm doing. Sorry. I guess we could have just done our standard window. Okay, that's better. So if we wanted to calculate our 0, you can do that and check. So we know this one is somewhere between negative 1 and, or no, positive 1 and 3. So we did that earlier in the chapter. It's 1.67, right? There's our answer there. And then if we do calculate our 0, and this one is between 1, 2, 3 and 5, right? We've got 4.27. So that's one way you could check to see if you've gotten the right solution. You don't have to use your calculator, just an option. All right, flip to the other side. So we're going to set up the same exact way. This one says you throw a baseball in the air with a starting velocity, so v equals 28. It even says, well, you throw the ball in the air, so we can assume that it's going upward, so it's a positive. The baseball is 5 feet up when it leaves your hand. So this is where it starts. So S equals 5. After how many seconds will it hit the ground? This is your ending height. Well, the height of the ground is 0 feet, so H equals 0. This is what you're going to see probably most often. So we've got H equals negative 16t squared plus VT plus S. Okay, so 0 equals negative 16t squared plus 28t plus 5. All right, it already is in standard form, so since there's an A, B, and a C, we're going to do quadratic formula. All right, so here's the, let's call this the quadratic formula method, and then we'll do it with the calculator in a minute. So it's opposite of B plus or minus B squared minus 4AC all over 2A. And then we just need to simplify. So negative 28 plus or minus 28 squared minus 4 times negative 16 times 5. That is 1104. And then I need what is the square root of that. Remember, we want decimals, not radicals, since it's a real life problem. You're not going to say something took like square root of 3 seconds. That doesn't make any sense. Okay, so now we're going to do negative 28 plus 33.23, then divide it by negative 32. So one answer is negative 0.16, and negative 28 minus 33.23 divided by negative 32. That gives us 1.91. All right, so the final answer, now if you think about it, how many seconds does it take for something to happen? Well, we don't want negative, so we can say it will take 1.91 seconds to hit the ground, the baseball, right? All right, so let's do it with the calculator method. You might like the calculator method best because that might be faster. All right, we're just going to take this equation and substitute it in our calculator. So go to y equals negative 16t squared plus 28t plus 5. All right, so hit graph. And we just need to find the zeros. So you go do second trace, find your 0. This one is between like negative 1 and positive 1. So that's your negative 0.16. And if you do calculate the 0 again, that one's between 1 and 3. So notice there's your arrows, right? Okay, so there's 1.91. So notice how much work that was versus how much work that is. You might want to just use this method. So let's do that for the next problem. All right, problem number 3. Fireworks are shot upward with an initial velocity of 125 feet per second from a platform, so that's your starting. So S equals 3 feet above ground. How long will it take before the fireworks, hit the ground? So this is your ending. H equals 0. All right, so let's do it all in the calculator. We're going to do H equals negative 16t squared plus VT plus S. So 0 equals negative 16t squared plus 125t plus 3. All right, so go to y equals, put that in our calculator, negative 16t squared plus 125t plus 3. Okay, hit your graph, and you're looking for where are the two locations. All right, so I see that one. So if I have my left bound, like, I don't know, between 5 and 9. So there is 7.83. I think there is another one over here. I'm just going to do that. But let's say between negative 9 and 2. I think it's actually right here. You can't really see the graph very well. So another answer is negative 0.02. But we know that answer is not valid anyway, so we can get rid of the negative answer. All right, so how long will it take before they hit the ground? It will take 7.83 seconds before the fireworks hit the ground. All right, last problem. We'll use our calculator again. All right, again, if you don't have a graphing calculator, you're going to have to use Quadratic Formula method. If that method makes the most sense to you, then do that method. All right, but I think this will be a lot faster. So we've got, you get a football from a tree 25 feet above the ground. So there's your starting. S equals 25. You throw it down, so that means you're going to have a negative velocity of negative 20 feet per second with an initial velocity of 20 feet per second. Just make sure that that's negative. How long will it take for the ball to reach the ground? So there's your ending, which is H equals 0. All right, so we have H equals negative 16t squared plus VT plus S. We have 0 equals negative 16t squared minus 20t plus 25. So it's really important that you have this negative sign right there. So let's do negative 16t squared minus 20t plus 25. Okay, so I see two answers. Now I know that I don't even need that negative value, right? We know that if we calculate it, we're going to get something negative, so I'll calculate it anyway, but we can toss that one out. Oops, I was going to do that one first. So that's between -5 and 0, let's say. Okay, so that's -2.02. But I know that's not going to be the right answer. So if I do it again, if you don't like typing in the numbers, just move your cursor. You can do that. But I could tell that's between like 0 and 2. It's really close to 1. If you need to see your cursor, you can do that. Okay, so we have 0.77. So the answer that makes sense is only the positive answer. Okay, so how long will it take for the ball to reach the ground? It will take 0.77 seconds for the ball to reach the ground. All right, if you think about it, you're just getting the football out of the tree and you're throwing it down, so it shouldn't take very long for it to hit the ground. You will have ones on the homework that'll say that you're dropping the object. So if anything ever says that it's dropped, right, then that means that your velocity is equal to 0. So it's possible that you'll have some problems where your velocity is equal to 0. But we didn't obviously have that on any of these. All right, you're all done.